Hello again, everybody. Sorry for the inconvenience. Did I hear you correctly that the coffee machine was broken on the rooftop? So we had a coffee break, partially without coffee. Sorry for that. But we are back in the room now. If there are some people still here on the corridor, please come in. We have networking drinks afterwards, so we can still continue the fruitful exchanges. So it's time for our session 2. I'll be just giving the intro, a few slides, and then I'll pass the floor to our dear colleague Pawel Wargocki. So in session 2, it will be Pawel's turn to moderate a nice and smooth running session in the same manner that Valérie did the first session. If you don't hear me, by the way, online, please drop a line in the chat and we will adjust. I hope you hear me. Then we have invited a couple of colleagues to give a more vertical presentation. So in the first part, we were more horizontal, let's say, EU level, even global level. Now we will dive in a bit in national technicalities and specificities. So first, we will go a bit in the Netherlands with Atze Boerstra. We will talk about the Dutch situation in terms of their environmental quality. And now the slide. Oops. And then we will have Valérie again, but this time as a speaker, to share with us the French situation. So we'll go then a bit further south in Europe and West. Similarly, we will have a moderated panel discussion, and this is the moment where I pass the floor to our dear moderator of session 2. So Pawel, the floor is yours. Thank you.
Well, thank you, Andre. So we will start the session 2 by having 2 presentations. As Andre said, 2 vertical presentations where we will be diving into how the EPBD is implemented in the 2 different countries. It's the Netherlands and France, and we will start with the Netherlands and my good friend, Atze Boerstra, who is a professor of building services at TU Delft, and is a part-time professor of building services, apparently. In the Faculty of Architecture and the Built Environment. He's involved in both research and education related to thermal comfort, indoor environmental quality, and HVAC technology. He's also managing director of BBA Binnenmilieu, a Dutch consultancy firm specialized in indoor climate and healthy buildings. And this is so special about Atze that he has this academic view and then his practitioner view, so which is really a very fantastic combination. He's a RIVA fellow, past vice president of RIVA, and former member of the TVVL board, which is the Dutch HVAC society. He was president of Clima 2022 conference that was held in Rotterdam. Nowadays is involved in national and international standardization work. So Atze, the floor is yours. 15 minutes to talk about the Dutch IEQ approach and implementation of the EPBD's IEQ provisions.
Thank you very much, Pawel. Yeah, before I start, I wanted to give a little bit of a compliment to EVIA and maybe to you personally. This breathing life into efficiency. I mean, it's like, how could you come up with that? Was it your idea, or I mean, so poetic? It was a group decision. Yeah, I was very impressed with that one. So maybe an applause for that one. I've been struggling myself with titles for events, and this one definitely wins the gold medal. So the Dutch IEQ approach and implementation of EPBD. I work half of the week at the university and the other half I work still as a consultant, and I've kind of decided to show a few practical issues that I see with the implementation of the whole EPBD thing in relation to health and comfort. So no detailed issues about certain sentences and how those are interpreted in the Dutch society, just a few general observations that we maybe all can learn from. One, of course, like if you talk about energy in buildings, people often think like, well, it just happens, energy use. Well, buildings don't use energy, it's building systems that use energy, like lighting fixtures, cooling machines on the roof, ventilators. If we are involved in machines for buildings, like EVIA, for example, we definitely have a big opportunity, a big obligation there to make sure that energy use, of course, is decreased, but also with an eye on health and comfort. And that is, of course, what we talk about today. There are 6 issues I want to discuss with you about, and I would like to apologize to the people from LightingEurope, because I also have an example related to lighting, but maybe you can ask me about that later. So, yeah, this has to do with daylight penetration especially, but ask me about it later. So there's 6 things I would like to address shortly. And these are issues that I see that are appearing because we maybe become a little bit too fanatic with energy performance, interpreting the EPBD directive. And these 6 are, the first 4 are directly related to health and comfort. So this is about installation noise, overheating issues, ventilation, fresh air supply, and personal control, especially personal control over temperature. And again, these are things I see that start to go wrong in practice with some type of projects, due to the energy policy we're doing. I'm putting this a little bit black and white, but anyhow. And then I want to shortly address 2 other issues that I see. One has to do with environmental impact of materials, circularity, and the other one with aesthetics. It's a little bit of my hobby. I work at the Faculty of Architecture. I have a lot of colleagues that are into making beautiful buildings and built environments, and I'm also a little bit into that. So I have just one slide about that. So if you talk on a party in the Netherlands with an average person about the energy transition, there's a pretty good chance they will start talking about heat pumps, and that the neighbors have them, and that they make noise, and that it disturbs their sleep, for example. I'm putting it a little bit black and white. But I think if we really want to convince the average citizen, at least of the Netherlands, then we should talk a little bit about all these energy technologies that could make a noise. Of course, you can design them in such a way that they are not very noisy, but in real life, often people select relatively cheap ones that really create issues. For example, rows, big arguments with neighbors. And again, there have been lawsuits already, etc. So we should not be naive. And if we really want to make sure that heat pumps are used more often, which I also support that idea, we have to look at noise inside, from your own installation, but also noise towards other buildings and towards the neighbors. Also, when you talk about heat pumps for offices and schools, etc. And I'm not sure that we're doing that enough. We should do it because, of course, in the EPBD directive, it says things like whatever we do, it should not make public health worse, and actually, ideally, should make it better. Same with quality of life. So we have to think about noise too, because we know noise can have a huge impact on quality of life and health in general. If you talk about noise, how do we address this in the Netherlands, in the Dutch context? Well, of course, there are like official rules about noise from outdoor equipment. In the Dutch situation, that is described in the so-called BBL. It's something new that we started beginning of this year. It's, I think in English, it's called Environmental Buildings Decree. So it's broader than what we used to have with just the building decree. And of course, on an EU level, we have directives about equipment noise too. So, but is that connected enough to what we are doing in the corner of EPBD? Question mark. And again, if you want to convince the average citizen in Europe that it's a good idea to do something with PV, like for example, transformers for PV systems with mechanical ventilation system, with heat recovery, with heat pumps. If there are too much noise issues related to them, you will see headings in the newspapers that you don't want to see. Values for what kind of target values you can use for noise inside buildings can be found, for example, in these documents. These are like standard programs of constraints we developed in the Netherlands for schools, offices, long-term care facilities, and homes. It gives like performance criteria at 3 quality levels. If you speak Dutch, you can download them through this website. Another subject. Oh, I see the flag is already there. Overheating. The Netherlands has a long history in looking at overheating in buildings, and we do have the habit of using not just very inflexible requirements, as saying that no matter what this week the outside temperature is, you always have to stay between 24 and 25 degrees. No, instead we use adaptive thermal comfort criteria, like the French do, I know. And it basically said that if you have a period where it's like a couple of weeks on the road, it's like 30 degrees outside, you can be more flexible and allow for higher temperatures inside, maybe going up to 27 or maybe even 28 degrees if you have a little bit airspeed inside. And of course, if you use very strict temperature requirements, independent of what the momentary weather outside is, and independent whether you are in Italy or in Finland, then of course you kind of force everybody into using air conditioning, active cooling, and in very high energy use. And maybe that's not something that's not necessary from comfort point of view. And it's also because it has energy penalties. So that's one thing I see in projects in the Netherlands, that people kind of tend to use very strict overheating requirements. And I would advocate that, for example, in schools and dwellings, we should definitely keep on using these adaptive ones. It is in the European, the CEN IEQ standard that was developed in the context of EPBD, the 16798.1. I'm in the position of working a little bit on that one, especially on the thermal comfort part. So of course I'm going to fight like a bulldog to keep the adaptive part in. There's a long history in the UK. The UK has done a lot of research related to adaptive thermal comfort. People like Fergus Nicol, Sue Rove, Michael Humphreys. But let's keep that in. We have a Dutch standard. It's called ISO 74. And then this is the picture on the top. Then it kind of also describes how you can do simulations with inside temperature and how you can present those in relation to the adaptive comfort criteria. We first came up with the graph, and then after we had finished it, because we wanted to use some color coding so you understand what it looks like. And of course, afterwards, we kind of noticed that it looks very much like a Dutch flag, which of course was very nice. You cannot do this in France, because then it's suddenly you don't understand the graph anymore. Yeah, and maybe if you lie on your side. Yeah, ventilation. So another subject that I see often in practice causing trouble. So from an energy point of view, especially in winter, you want to ventilate as little as possible. Kind of nonsense, because if you have good heat recovery, it doesn't cost that much energy. But anyhow, within a lot of project, people are saying like, okay, we need to do more with energy, so we should ventilate as little as possible, especially in the winter. And I think this is a problem, because we know from the COVID pandemic that it's really important to ventilate spaces really well, because otherwise you have a higher risk of transmission of viruses through the air. And yeah, luckily we now also have advice, for example, from WHO that basically says, well, from fire safety point of view, you should ventilate at least 10 liters per second per person. There was recently a science paper that some of us, including Pawel, worked on, that basically said you should maybe go for 14, 15 liters per second per person. It's not that simple. We have to look at ventilation efficiency, the context, are people singing or not, etc. But anyhow, we do know that what we now do in the Dutch building decree, BBL, sometimes it says 2 liters per second, 2.1 is good enough in existing buildings. I think we should have a discussion all over Europe about the different building degrees. What kind of are the limit values in there, and is it like that far off from this 10 liters per second or not? I think like designing with 2 liters per second per person in the back of your head, like a bedroom for 2 persons and then maybe 4 in total, that's just way too low for all kinds of reasons. So that's definitely something I see often in practice being discussed. Then this is a little bit of a hobby of mine. I once wrote a PhD thesis about it. You don't know it, of course, you can all download it tonight. It's on the right, but I see a lot of parties in the Netherlands, and maybe it's just a lack of intelligence amongst the Dutch people, but they read the building automation and control systems paragraphs related to the last version of EPBD, and they read it as if we now need to monitor energy, we need to monitor indoor climate, temperature, for example, maybe CO2, and because we need to monitor it, we have some kind of criteria like bandwidth we have to stay within. And because of that, we should people not give control anymore, because then maybe one day the temperature might be outside the bandwidth. I'm not joking. I've had 3 projects of people. We basically said, because of bugs, we cannot have personal control anymore. So no adjustable thermostats on radiators, no wall thermostats in offices. It's now forbidden because of bugs. That's basically what they say. I think they misinterpret the text, but I think it's we really have to talk about this, because I think it's a very bad idea, because we know that if people have options for personal control, Pawel already said this too, we know that people have increased occupant comfort, better perceived health, and also it positively can affect productivity. And I know from eu.bac, like a couple of years ago, also looked into the issue and basically said that it can even save money, not just in a residential context, but definitely there. And it can actually also save energy, because you know much better to keep the temperature at a certain level, and it doesn't go like this if you have like an open closed kind of valve. So let's have a talk about this. Very important. Then, so the last 2, yeah, maybe crazy stuff. Do you have 2 more minutes, Pawel? About 4. Okay. Another thing that I worry about a little bit, and that's really on the agenda in the Netherlands, especially at the university, I have a lot of colleagues that are really into circular buildings. And then if you're into circular buildings and you do a little bit of research, you will find out, and see the quote on the above on the right, that especially if you renovate buildings and you reuse columns and floors, etc., that then the hidden environmental impact of the materials you use. Often when you do deep renovation, you change the heating, the electrical wiring, the lighting, the cooling system, etc. So there's a lot of metals involved, copper, aluminium, you name it. That the hidden environmental impact on the side of just installation and replacement of installation goes up to more than 25% of the total environmental impact of the renovation. So it's a huge impact, and I think I'm trying to convince REVA also to put this higher on the agenda. I know the next version of REVA, I think maybe 2 after next, there will be an article about this, but we have to talk about this. And then, of course, if you do the right thing on the energy performance side, install a heat pump, for example, often the thing you use to improve energy efficiency at the same time has a much higher like material impact, environmental material impact than what we used to do. Like a standard gas heater that we used to do in a residential context uses maybe 1/3 of the amount of metal that you use in a heat pump. And I'm not saying that we should not use heat pumps, but if we do have a discussion with each other, we should look at energy, we should look at environmental impact of materials, and we should look at health and comfort, and not just about at only energy on one hand and health and comfort on the other side. Of course, we have also legislation coming related to circularity and environmental impact of materials, so we cannot put our heads in the sand here, as we say in the Netherlands. This is my last remark. A friend of mine, he works for what we call the welstand in the Netherlands. This is something really Dutch, I think. In the Netherlands, whatever we do, I'm not going to make any jokes about Belgium, but whatever we do in the Netherlands, if you change a city or neighborhood or a row of houses, you kind of have to go to the welstand and they will look at it if it's beautiful or not. That's basically what they do. So like it's aesthetic building inspectorate, I'm not sure how to say it. And again, these pictures are from projects that kind of slipped through Welstad. It's from a friend of mine who works there, and René Heijnen. And he was not too happy with this one, for example, because the color is just off from this. So maybe make it gray or make sure it's also made out of brick. There's some heat pump in here. And also the one in the middle, of course, you get these little gray things. The outside unit of your heat pump, that I'm not sure that I would like to look at that if it's my neighbors having them. If I have them myself, it's okay because I don't see them. But on the other side, and as the example of the left, that's of course an existing situation. Yeah, I think there are more subtle ways to include some PV panels. And I'm a little bit afraid that if we don't think deeply about this, Europe will become much more ugly than it is right now. If we just put all kinds of energy technologies on and around and on top of buildings without thinking about aesthetics. So think about this. So my last slide, take home message from the Netherlands to Europe. Yeah, further implement EPBD, very good idea. I also support this strongly. I think we should even actually hurry up things more than we're doing it right now. Energy performance, energy transition is very important, but let's really keep a keen eye on issues that are happening in the corner of maybe installation noise, inside and outside, overheating. Let's avoid too strict summer requirements. It definitely has a dimension in the energy corner. If we talk about ventilation, let's have a discussion again. I'm sure Pawel is very happy about this, about how much fresh air supply we need, and are we not forgetting about all the health effects in that corner. Definitely, let's talk about personal control over temperature. Let's not lose that. It's very important to have it and to keep it. And we should address environmental impact of installation materials and aesthetics. Okay, I think that's it. Thank you very much. Because the Netherlands would have won at the Eurovision Song Festival with this song, I think. If they wouldn't have kicked out nobody from Sweden here, I think. For the panel.
We will wait with the questions for the panel, if you allow me. So please remember your question, and we will start with the questions to the presentations, maybe. Then Valérie is for the second presentation, and Valérie is the project director of indoor environmental quality at CEREMA. Is an expert in building ventilation, air tightness, and indoor environmental quality. Currently, she serves as the project director for indoor environmental quality and ventilation at CEREMA. And for those who don't know, CEREMA is a public research and design office in France. She leads national and European working groups to ensure consistency between standards, regulations, and latest research findings. Her responsibilities include initiating research projects, such as revising the ISO 9972 standard and managing submissions for major European projects for Horizon 2020. As the convener of CEN-TC 156 WG23, you'll have to explain to us what does it mean. Anyway, she leads the revision of the EN 16211 standard. And for AIBC tight vent, she's a coordinator of the Tight Vent Air Tightness Association Committee, working on air tightness and inspection of ventilation systems.
So,
The floor is yours. Thank you.
Thank you very much, Pawel. And so I will talk to you about how we have already started in France to implement the quality provisions that are in the EPBD directive. Well, we are not quite there yet, but we still have done something in the previous regulation. So, as we have already discussed in length, indoor environment quality is a new focus in the EPBD directive. This is directly in Article 1, and we even have a definition of indoor environment quality, which includes temperature, humidity, ventilation rates, and presence of contaminants. And all this need to be taken together with the energy performance of buildings, which is a very good thing. So you will see my nice icons here. It's not done by IA, it's done by myself, and I'm very bad at doing those kind of things, but that's supposed to say dwellings, single, multifamily, and that's non-residential buildings, that's new buildings, and that's refurbishments. And this will be useful for the rest of the presentation because some of the regulation apply to one or another. I should try to use IA to do those things better. Okay. So in Article 5, we say the EPBD directive say member states shall take necessary measures to ensure energy performance requirements, and those requirements shall take into account indoor environmental quality also in it. So what we have right now in our energy performance regulation, which is called ERCO 2020, which means that it came into application in 2022. We always have 1 or 2 years after our objective, but that was because of COVID. We already have this thermal comfort assessment, as Atze was saying. We've got in the regulation indicators on 3 subjects. One about life cycle assessment, well, actually 2, full life cycle assessment of the building, about the energy use, the use of primary energy, and encourage renewable energy, etc., etc. So we've got 3 indicators on this topic. And then we've got one about thermal comfort, which is actually the sum of the difference between the actual temperature and the comfort temperature during the summer outside heating season. And this comfort temperature is actually adjusting around the time, because if you've got like 10 days at hot temperature, it's adaptive comfort, so this temperature increase. And we've got a limit on this degree hour of discomfort. The calculation is performed, it's a hourly calculation, and this regulation is really performance-based. That means that we've got very few prescriptive requirements in it. We just need to reach those indicators. In existing building, well, we still have, so you see, new building, orange ones, on my topic on here. In existing building where we are not quite there yet, we do have a regulation that apply to indeed very big renovation in some kinds of building. And we do have an indicator for thermal comfort. We calculate the temperature that is reached after 5 odd days. And there is a limit, but that is building dependent. So this limit can actually be really high. For example, I had an example once where the maximum was 32 degrees. And so as long as we were below 32, it was okay, which is not, so this indicator is not very good, but we should revise this regulation soon, whatever soon may means. Now, this is for temperature, but it's not the only focus of the EPBD. The EPBD also focus on health, and health include indoor air quality. For that, it's not included in the energy performance regulation. It's another code that makes the requirements on indoor air quality in France. We've got the construction codes that say, okay, air renewal should be such as in normal condition of use, the indoor air pollution does not endanger the health and the security of occupants, and that condensation is avoided except temporarily. So that's the construction codes. And then we need to say, what does that mean actually? Because that's, well, quite easy to say. So in the regulation, we say, okay, it's okay if it fulfills the prescriptive requirement from 1982, which gave, flow rates, a bit like everybody per room. But it is also okay if it fulfills new key performance indicator levels that will be defined within 2025. So we are actually working very hard on it to be ready for 2025 and define those key performance indicator level that ensure that the health, well, actually is not endangered in our building. So as I say, this is a prescriptive regulation that will stay, that will remain as it is, but we will have a new alternative, which will be performance-based. And that's what we are defining right now, trying to establish what will be the indicator and how we will come to check that the ventilation system actually do not endanger the health of the people in it. So to define those key performance indicator, we have first had to think, what is the objective of the indoor air quality management strategy? What do we want to reach? We got objective on health. We want to limit the exposure, long-term and acute, to pollutants emitted by the building and by the human. By human, I mean by human activities also. We have objectives on well-being. We want the system to rate the impact of the system on the sleep quality, on the stuffiness in room, and we also want a certain level of perceived air quality. For example, when we are talking only about residential buildings here, the focus here is only on residentials. We are not talking about non-residential here, only residential. A level of perceived air quality in the toilet, for example, and we've got the risk of condensation that may affect the building durability. Starting from defining the objective, then we say, okay, how we want to assess that in the design stage. So we want to assess that through preliminary simulation. We have talked about a bit before about the indicators that were not the same when we were doing the assessment in the design phase for the monitoring or during the commissioning of the building. And here we only focus about the preliminary simulation, so in the design phase. And we want to have threshold values that are consistent with what our system what our systems are doing right now. So the systems that are consistent with what we call arrêté 82 do, we will have threshold values that are consistent with that. And so here is the indicator we have basically chosen. First of all, it's very important that it's not possible to assess indoor air quality just with one parameter. So we say, okay, actually, to have a requirement that is equivalent to our prescriptive requirements, we need 5 parameters. One on CO2, one on humidity, one on fictive pollutant P1 that is emitted continuously, one on fictive pollutant P2 that is emitted during cooking, basically, and one about air renewal rate. And even for each parameters, we have 1 to up to 3 indicators associated to that, okay? And then we have a target value for this. So the values that are given here are not validated yet, but given the results of our simulation, it should be more or less that. So that's very, very high, but that's actually how our systems are right now performing. So what we have done is that we have done more than 2,000 simulations with the 2 systems, and on a series of buildings that are consistent with the building stocks in France. And so we say, okay, the objective is that 75% of the simulation meet the new threshold value that we will define, so that we have 2 regulations that are consistent with one another. And that's how we get those values. So to sum up, regarding indoor environment quality, we've got rates, the French regulation rates indoor environment quality of buildings through simulations. It has requirement on thermal comfort for every new building and for some refurbished building. It rates indoor air quality solely for residential building only, but we still need to develop indoor air quality performance indicator for on-site rating, measurement and monitoring. We need to develop indoor air quality criteria for non-residential buildings, and we need to develop monitoring requirements if we want to fulfill the EPBD directive. Before I finish, I would like to also insist on the inspection of ventilation. So Pawel, you were asking TC156WG3 mean working group 23, sorry, about inspection of ventilation system, to which I happen to be the convener at the CEN European level. And in the directive, there is this Article 23, which is very important, that now imposes a regular inspection of ventilation system together with heating and cooling system for systems that have an effective rate above 70 kilowatt. So that means that big system will need to be inspected every 5 or 3 years. So what we have in France now in a regulation is a mandatory inspection at commissioning, only at commissioning, for every new residential buildings. Again, it's only focused on residential buildings, unfortunately, but yeah, our regulation is 40 years old, so we now know quite well how to inspect those systems that are all the same. So we do have a protocol, and we do have this mandatory since 2022. This is done by a qualified inspector that is independent and with the whole process of training and validation. And for one thing, we are also ahead of schedule. In Article 24 of the EPBD directive, you've got the mandatory database that need to be set. That means that all inspection reports should be uploaded in national database. And that's actually what we do. We have this National Observatory for Ventilation, where every inspection report are uploaded, and that will provide public statistics. It's not yet available because we need to have enough data to make the statistic online. Otherwise, we would be able to spot which building has been inspected. But within a few months, it should be done. And for non-residential building, well, we do have a protocol, which is already done, but it's not mandatory yet. So to conclude, the challenge for the coming year, at least in France, will be to build something for non-residential building, make indoor air quality requirements, make a mandatory inspection protocol at commissioning and then every 3 to 5 years. That's the big thing. Regarding renovation, we need to build this renovation plan. I was talking about it, and we need to include it indoor environment quality requirements and inspection protocol also for those refurbishments. We need to develop smart readiness indicator as required in Article 5, also including the resilience of building. And we need to work on building automation control also. In standardization, well, we still have challenge. As I was saying, I'm in charge of 16798-17 about the inspection of ventilation system. And these standards need to be revised to better tackle the question of demand control ventilation system, because this is probably one of the answers to good indoor environment quality while controlling the building energy use. We have to better tackle the inspection of indoor environment quality also in this standard. Actually, we just check the flow rates basically at the ventilation system, and also tackle the question of the regular inspection. That is not the same as the inspection as commissioning. And in EN 16798-1, we need to develop also care performance indicator for indoor environment quality to give guidance to member states to develop their own performance indicator as required in the EPBD standards. Thank you for your attention.
Thank you very much, Valérie. May I ask Valérie and Atze to maybe take a seat already at the panel? Maybe before we start with introduction of the other panelists, if there are very quick questions to the two presentations, because I remember there was one.
My question is for both. What is there for lighting? Dutch and French. Thank you.
Traditionally, in the Dutch building code, there are requirements about daylight penetration, especially, and that's also the example I could have given. That now sometimes you see that when you design new buildings, that certain designers try to make the windows as small as possible, because then you don't have overheating, and of course glass is a bit less well insulating than the non-glass parts of the facade. So I've been in some projects where people were trying to make the windows as small as it is allowed because of the building degree, now called EVIA, and then you end up with really small windows. So we don't have really strict, specific requirements about lighting levels. Of course, the 12464-1 that you refer to is used a lot in the Netherlands when you design like offices. But in the building degree, it's only about daylight penetration, especially not for all kinds of building categories. Yes, that's there.
Okay, I am not a daylight expert, I admit, but in the regulation, we have the energy used for lighting that is included, and we've got requirements on access to daylight also, not directly, but area of windows per room that is the minimum of that. So that's basically the two things. I'm not exactly sure what else is required in the French regulation, so I won't go further with that. Sorry.
There was one more question.
Yes, it's actually a question for Valérie. When we look at the indoor environmental quality definition, we see that we talked about ventilation rates and also humidity and also level of pollutants, which are problematic for the health and well-being of the people. You presented the French scheme just a few minutes ago, which is going to allow, on one hand, the arrêté de mars 82 for ventilation rates, and also the possibility to rely on, let's say, levels of indoor air quality for buildings. Would you believe that this combination would be fit for a French transposition of the EPBD as far as the French legislation is concerned regarding indoor environmental quality?
Well, I think that setting indicator for indoor environment quality is the first step, and that's what we have done with this working group, setting indicator. So in my view, yeah, this is the first step to implement it, but we still need to work in non-residential building where it's not done. For residential building, I think, yeah, we have done part of the job here.
Sure, question. You presented numbers of CO2 and so on. And then you said these are based on that 75% of the current building stock meets these numbers.
Through simulations.
Through simulations. So why 75% is chosen? Because you should use the health base and not the statistics.
Okay, so that's, of course, you already have asked the question thousands of times. So in fact, we've got two regulations that will coexist, the prescriptive one and the new performance ones. Every project will have the option to go either through one option or the other. So the idea here was that the two regulations was imposing the same thing. We couldn't have a regulation that was very light, like it's very easy to reach, and another one that would be very strong and very difficult. So the first principle when we define this regulation, we say, okay, the threshold must be consistent. And then we will be able to develop a label, we will be able to go further in the next step. But the first threshold that we define are the ones that are consistent with the prescriptive regulation as the two different options.
Have you considered intermediate process? So
Next step.
setting the very high objective, but having this regulation as an intermediate level to get to the other one.
That's the next step. The label things. The objective is to have those indicators to actually be able to, for systems that are doing better, to actually show it. Because right now, a system that is performing better than the basic system is not able to sell itself.
Right.
The customer will say, okay, what's the point? We use more energy, so then why? Is it better? No, it's comply with the regulation, so that's enough for us. Here we can say, okay, this is actually performing 50% better than the minimum requirement, so that's the notice. That's the first step.
Thanks, Valérie. And thanks, that will conclude the presentation of the two plenary speakers and then our keynote speakers, and then we will go into the moderated panel discussion where we will have additionally to Atze and Valérie 4 other panel members. And we will start with the first one, Tyler Smith, and he's a Vice President of Healthy Buildings, HVAC and Controls at Johnson's Controls. He came to us specifically for that meeting from United States, right? So Tyler has spent 19 years with Johnson's Controls in roles focused on leveraging building management systems and HVAC equipment to drive important outcomes such as improvements of energy efficiency, health, wellness, and productivity. From 2018 to 20, led Johnson's Controls Critical Environments Business Unit, which designs and manufactures systems for critical spaces such as hospitals and laboratories. And late 2020, he beginning late 2020, founded and scaled Johnson's Controls Global Healthy Buildings portfolio, which is focused on helping building owners leverage productivity and financial outcomes associated with operating healthier buildings through improved indoor quality. In January this year, Tyler took on an expanded role with additional responsibility for management of the global HVAC and controls portfolio. Please, the floor is yours for a short introduction.
I'm going to hire Pawel as my hype man and take him around to meetings with me. And I had a joke in there about guessing where my accent was from, but he stole it, stole the punchline. So sorry. That's okay. I'm very honored and pleased to be with this esteemed group. Thank you so much for having me. Thank you to eu.bac for hosting me and Johnson Controls as part of this group. It's really an honor, and I have just been eating up everything that we've been talking about so far. What I hope to contribute to this short couple of minutes here, but really to the panel discussion, is the perspective of what it takes to make this stuff happen on the ground. We've talked a lot about the why, and actually you'll recognize some statistics, even a graphic there in the middle,
that's already been presented to you today. So I believe in this room, and with some outside of this room, the why is already well understood. We've got statistics. But what it takes to actually make this stuff happen on the ground is where we need to focus our efforts. My team and I think about this every day in front of customers, in front of prospective customers who are trying to make this decision. Do I invest in this, yes or no? And oftentimes it comes back to return on investment. There may be some carrots out there for me to do it. There may be some sticks out there to encourage me to do it, but it needs to make good business sense. So I've got a statistic on the top middle of this page here that I'll direct your eyes to, €800 per employee per year. That's our conclusion after going through a lot of the existing research out there on what is the business justification of investing in improved IEQ. And I think Pawel may have been an author on some of the papers that we referenced there. I want to focus this though as I finish up here on the right. We've talked a lot how it could be costly to implement IEQ measures. Costly versus what? What baseline? That's something that I'd like to explore in the panel here in a minute. But we've also got this force acting upon us, this pain point of occupancy rates in buildings, especially commercial buildings, are not what they were designed to be. And so my challenge to us is, as we consider energy efficiency measures and improvements, we've got to use IEQ as a KPI. That word indicator has come up a lot already this afternoon. That should be our minimum in some cases. We cannot improve the energy efficiency of a building without also being mindful of the impact on humans that occupy that building. So thank you for having me. Thank you for including me in this discussion. I look forward to talking more here in a minute.
Well, the next panelist will be Pierre Cruveillé. He's the chairperson of EVIA. And Pierre was appointed as a public affairs director of the Aldes Group, a ventilation system and heat pump manufacturer, in October 2016. He oversees relations with political, administrative, and institutional bodies at the European and French levels. His core mission is to support the development of adequate legislative and regulatory frameworks, allowing to take on the challenge of making the buildings of tomorrow more energy efficient as well as healthier through the improvement of their indoor air quality. To this context, he actively took part in the revision of EPBD, renewable energy and energy efficiency directives, and is also involved in drafting of new French building regulations. Pierre holds a degree in business and European management and has 25 years of experience in governmental relations dealing with energy and environmental issues. He has been elected president of the European Ventilation Industry Association Steering Committee in 2024 and is deputy chair of the Ventilation Strategic Committee Bureau of UniClima, the French Union of Thermal, Hydraulic and Refrigeration Industries. Please, Pierre, the floor is yours.
Thank you very much, Pawel, for these introductory remarks. I'm going to focus also on how we can implement this new text. I'll just come back on a few aspects. First of all, I think that everybody will agree that we've made a very great step forward with the revision of the EPBD. I mean, we were very much lacking elements on indoor environmental quality, indoor air quality in European regulations. And I think this new directive is completing the overall framework regarding buildings. And I think it's also the right place to develop such requirements because, of course, in buildings, it was said earlier on today, we have clearly an energy efficiency part, which is key, but we shouldn't forget at all about making sure that these buildings are fit to be lived in. And I think that it would have been completely not understandable that after the COVID crisis that we didn't have any regulations on indoor air quality at the European level. I think that also this sanitary crisis has put a great focus on the link between health and indoor air quality, and especially the fact that when you have a very low air renewal rate, well, you substantially increase the risk of health affection, and there was a clear interlink which was made in many scientific studies between the SARS-CoV-2 infection and very low ventilation air renewal rates. And Pawel, you mentioned earlier during your speech the clear consequences from a health and economic point of view. Clearly, if we want to avoid this problematic situation, we have to ensure that in all buildings we have a sufficient air renewal rate. And this means that we need to comply with minimum ventilation rates. And at the same time, we don't want to have uncontrolled air renewal rates. We want to make sure that this is limited to what is strictly necessary to ensure an appropriate indoor environment. And in this regard, I believe that mechanical ventilation has a great play in this field. Of course, it's very much important. I should have done that earlier. Of course, it's very much important that this technical building is well dimensioned at the start, that it's well implemented, that it's maintained throughout its whole lifetime to deliver its performance. And here, I'm also very much pleased with the EPBD that now it's going to make compulsory the inspection of standalone ventilation system. And I would finish my quick speech with a final comment, last but not least, is that we have to make sure also that the member states clearly enforce these provisions on the ground. I'll just take a small example of the French situation, where we have in our regulations a requirement that in non-residential building we shouldn't go beyond CO2 ppm limit of 1300. And in fact, when you look at the situation in many educational buildings, you realize that you're way above this limit, and it doesn't seem to bother much people. And I think this is really what is at stake in the implementation of the EPBD revision, is to make sure that these provisions are fully implemented and respected. Thank you.
Yeah. Keep the mic. Now we have a Thomas. Thomas Schielke is the architect and lighting design trainer at LightingEurope. Has worked as a lighting design trainer at the lighting manufacturer ERCO for more than 20 years. He has taught lighting design at different universities and was invited for lectures at institutions like Harvard, GSD, MIT, Columbia, GSAPP, and ETHZ. He studied architecture at the University of Technology in Darmstadt, Germany. His doctoral thesis at the same place has analyzed architectural lighting. His research interests focus on qualitative lighting design. His column, Light Matters, on the architecture blog ArcDaily reveals various perspectives of architectural lighting. I invite you to read this blog. And then he's co-author of the books Light Perspectives Between Culture and Technology and Superlux, Smart Light Art Design and Architecture for Cities. Thomas, please.
Oh, thank you very much for the introduction.
Okay,
that's perfect. Thank you. So today we have the opportunity to work with very efficient light sources, and therefore we have often focused a lot on energy efficiency. But a very important aspect is actually the quality of light which we could get there. For example, in such a building, we could ask just for basic quality, just to see anything in a building, or that we can really appreciate the building. And the quality of a building is also how much is it used. If we create very attractive spaces where the public, the younger generation and the older generation would like to go to, then the building is actually used. But if we just install the minimum light quality, then probably people will not find it very attractive to go to the library, to study there, to learn something there. So therefore, we recommend really to consider this aspect. It's similar like food. So you could think for dinner, for example, a very nice, easy instant soup to do this. For one evening, it might be okay because you might be in a rush. But just imagine eating instant soup for 10 years. So it's more really about the quality of food which you have there. And therefore, we are asking to create not the minimum lighting quality in a room, but a sustainable quality. And therefore, you will have benefits for well-being. We've heard about something about the health, the circadian rhythm, the changes which are there. And so it's also really about figuring out how we can actually control this afterwards there, not only planning it, but also making sure that it's installed there. And today we have even metrics available where we are not just asking how much light is coming out of a fixture, but actually how much light is perceived by the eye in the area where you're looking at. So when you look forward, you would like to have something in the background to see it, and not just on the floor plan to have lights there. And these kind of aspects contribute to a very good quality for interior spaces. And therefore, I can only highly recommend to make use of light on a national basis as well, to have a more sustainable architecture with a very good indoor interior quality. Thank you.
Okay, the last panelist, Adam. He doesn't need an introduction because he was introduced in the first session. So those who missed first session, they missed the introduction to Adam. So I think maybe because we really want to make the time on some discussions. But Adam, please, if you have few slides here.
I haven't particularly got any slides, but just a couple of things.
Okay, please.
BB 101 I mentioned earlier on, and as we've been crying out for a bit of light discussion today, BB 101 was all about thermal comfort and the performance of classrooms. And it fundamentally changed the way schools in the UK lab. They placed a much bigger focus on daylighting being available in those schools. But a big part of that was around thermal comfort, and the BB 101 uses adaptive thermal comfort. It's a development beyond CIBSE TM52, which is pretty readily used in the UK. We're very fond of using windows for controlling temperature and providing ventilation in the UK, and a lot of that is driven by our climate. It's never that hot, it's never that cold. We talk about this weather all the time, but it's never particularly extreme. In fact, that's probably one of the reasons why we've got some of the leakiest buildings in Europe. So right now, we're tightening up the fabric of our buildings, and then we're making large holes in it so it can breathe. Initially we didn't, we just tightened them up, caused lots of problems. Now we are putting holes into the building to let them breathe. We're not quite there with heat recovery systems yet because of our climate. It hasn't been a real necessity, but it will be as we continually strive to improve the energy efficiency of those buildings. The next thing that we have to struggle with is there's no one to install them, and that's why we're here with GCP and EVIA to start to train these people who are going to be required to fit correctly and maintain those heat recovery systems that are needed. And I'll finish there.
Thank you. All right, so let's start in the last 15 minutes, the panel discussion, and a couple of questions that I may have or the panelists suggested, and also I will allow the audience here to ask the questions. And also if there are anyone online staying with us so late on Monday afternoon, you are welcome to pop in the question, and then we would be trying to address those. I think I would really like to start with a couple of comments, general comments, is that there is a lot of challenges ahead of the introduction of the indoor environmental quality as a regular parameter in the design and operation of the buildings. To me, I mentioned some of those, and still there is a lot of pushback that is created, and also a lot of complications. Therefore, because we have such an esteemed panel here, and because it's a Monday, and because it's a late afternoon on Monday, I would like to challenge the panel. And also, I would like to learn that we audience here and audience at staying late at the computers, just to maybe create a list of the actions that need to be made, the most important, that we could start, using the indoor environmental quality on a par with energy. So we will be just discussing how we make it through that indoor environmental quality will be considered as an important parameter, not parameter for designing an energy performance, but the parameter that is actually considered as the important parameter for the design and operation of the buildings and for the occupants in the buildings. And we have a panel of people from different, disciplines with different, backgrounds and so on. So maybe who wants to say what would be the most important action that should be taken, or what should be done in order this IEQs that is discussed so much, and we know so much about it, is just at last considered seriously when we are talking about buildings. Who wants to start? Please.
I'll continue a theme that I introduced in my remarks, that we know a lot about IEQ. We know a lot about the value. By we, I mean people in this room, people listening in, if I could use the phrase, the echo chamber that we sometimes find ourselves in. But we need them to know. We need them to get it and want to invest, not just because they're required to by some code somewhere, but because it's the right business decision. So that's why it's so critical to translate everything that we know to be true down into easy, digestible facts and figures and numbers and calculators and ROI models that a business leader can use to make a well-informed business decision also. That's one of the things that I hope and expect comes out of the work over the next year or so, is we want these member states, the companies operating in these member states, the governments that own buildings to want to do this because it's the right thing to do, and it's going to make good business sense for them. My thoughts.
Thank you. Valerie, maybe?
Yeah, I think I show that in the French regulation, we have got the low carbon, the energy, and then the thermal comfort. I think the thermal comfort should not just be the thermal comfort, and we should have additional indicator from the start when we design the building at the same place, rating everything. So in my view, that's the first thing to do, to really have indicator included in the energy performance regulation and calculated from the very beginning at the design stage. The first step is to have good indicators, and that's a difficult step.
Pawel, you asked for concrete ideas about concrete actions.
Yes, exactly.
I think Delft is a good example. There are some changes on the political landscape all over Europe, a little to the right here and there. And I think it's good maybe to kind of rephrase what we are talking about, because yes, if you talk about greenhouse emissions, saving the planet or whatever, maybe certain parties are not that involved, but if you combine it with a message, then maybe we should be much bolder about this, with something about health. I mean, parties to the left and to the right, especially if you make it obvious that also people with less money are, I don't know, maybe suffering from moldy houses or living close to the highway, so they are exposed more to a high concentration of particles than the rich people living in the big villas. So to kind of think a little bit about what we talk about, we are maybe a little bit too modest about what we do. I mean, this is all about, yes, saving the planet, diminishing greenhouse gas emissions, but also about, is a good opportunity if you change, for example, facades of buildings, to also improve, really improve health and comfort of people. And now we maybe talk a little bit too much about, like, oh, we are doing all this stuff because of energy. And by the way, on the side, we also help a little bit efforts European to become a little bit less unhealthy. So we should rephrase the message, right?
Tom?
I think it's a win-win situation when we have the opportunity to renovate our buildings, and just to look on the energy efficiency. That's what you're pointing out. There's actually a second take. We can improve the quality for a wide range of people and addressing multiple aspects like well-being, health. Those issues are quite critical. And so when you do something, then do it really and make the best out of the money when you invest it.
I think we need to make the whole issue sexier than it is at the moment. People spend a lot of money on food they eat, they go to the gym and do things like that, but what they breathe and the light and sound they're exposed to, they're just not interested in. And another issue that I'm quite passionate about is public information. We still have test your smoke alarm videos. We have videos telling people not to get too close to the car in front when you're on the road. The number, I don't want to talk about death all the time because that's not sexy, but the number of deaths from air pollution exposure is so much higher than fires and road traffic accidents. And yeah, there's no funding.
Yeah.
Yeah, just a compliment to what has just been said. I think some people were perhaps a bit disappointed about the result of the EPBD, but I think it's a very positive result. And clearly, I've heard Pawel say on a number of occasions that it's the best year that we expect. And I agree to that. What I think that is important is that the situation is very much different from one member state to the other. Some member states are already quite well advanced in this indoor environmental quality or indoor quality issue, and some others are really starting from scratch. I think one way to make it a success is to make sure that those who are really starting from scratch, that the guidelines, the support that will be brought by the Commission and other entities really allows to operationalize those requirements. And for me, for those who are really lagging behind, to make it really simple and to concentrate on a few indicators which are essential and which will already make a huge progress, i.e. ventilation rates, CO2 concentration, humidity range. I think this will be already a very good step in the right direction.
So let me conclude this, because it's a great list of action items for the future. It's like make a business case, start to use this not as a result of action, but at the design level at the same time, change the language and rephrase how we talk about this. And then we have to talk to people. People may be aware of this, and then make it more sexy, and then we need indicators. So this is basically a very nice list of action items, how we can make it happen in the future. However, I would like to challenge you with one of parameters that was not mentioned. And often this is one of the parameters that is considered and discussed a lot, is the separation of responsibility. So in the building renovation or building process or building construction process, there are different stakeholders which have different interests. And that those interests may not be, how to say, aligned with the final user of the building. So how do we deal with that problem? Because say I am the investor, I'm interested to basically sell the building in the end. I'm not interested whether people are healthy in it or not healthy, maybe. I just want to make my money for my investment. And maybe there is a building owner who is renting the spaces to people who are there, and maybe that he may or she may have a different objective, and so on and so on. So what to do about those, responsibilities? And it talks about that.
I think it would be worth to consider something in the business environment. You talk about the total cost of ownership, maybe over a period of 20 years, so the very long time operational time, and then just linking this with a more ecological factor to see the benefits, and also maybe a metric for the interior environmental quality there. I think not calculating the first year for the investor, or maybe the second and third, but really taking into consideration a 20-year period of a building And of course, we know actually our buildings will probably last, will built in a proper way, 40, 50 or more years. So it's just the first step as a compromise actually to the long-lasting building.
Decision makers that are operating, designing, funding buildings are buying outcomes, buying things that you're going to deliver them that are going to help improve their operations, help them make more money, makes their building more attractive, etc. So I think it goes back to business justification and ROI. We flashed a lot of statistics, facts and figures, proven by data and proven out in practice in the field, that get at outcomes that are important to each one of those stakeholders, Pawel, that you listed.
Right.
We've got to shift how we talk about it to the earlier point from we need an IEQ sensor to measure CO2 and PM and TBOC levels to I understand that this outcome is important to you and to your operations or to the design that you're pulling together or this building that you're funding, et cetera. And I guarantee you that we've got a statistic of improved indoor environmental quality and air quality that aligns with outcomes that each of those stakeholders would share.
Thank you. Anyone? Oh, please, Pierre.
Yeah, you were saying that interests are not aligned between people who are living in the buildings and people who are selling in buildings. And I think you're right. And one way to overcome this, clearly legislation is part of it because this will impose conditions on the builders to comply with a number of requirements. If we want to go one step further, I would say that it's the education of the people living in the buildings. The more they will be educated, the more they will be prescriptive in what they want as far as buildings are concerned. And this is where we can go the extra mile with people actually requesting buildings which are more efficient also from the indoor environmental quality point of view.
Thank you. All right, so, okay, thanks. So let's close that series of discussion. Maybe I would like to hear your opinion Valérie presented the definition of indoor environmental quality in the EPBD, and there is no noise that was raised the point by Atze, and then there is no light. Any comments on that? Pawel is not here. How we can just make sure that maybe those two parameters will be considered as well?
Yeah, I always wonder about that. I was involved also with some other initiatives related to our group, for example. Some people might know that. And then also there at the start there was some talk about noise, and then the second version they threw out the noise part. The person was very noise sensitive. So I think if you took your own tail study, I mean, it clearly shows that it's the combination of the four things that makes how you perceive an environment. Some people are sensitive to bad lighting, some people are sensitive to bad air quality, some to noise. But to come up with requirements about just temperature, like really strict temperature requirements, which forces people into maybe creating bad air quality and really noisy systems, that's not going to work. So it needs to be an integral approach where you address those four issues at the same time. And of course, you can, first step can be that you focus a little more on air quality and ventilation, because we all together did maybe pretty good work in terms of lobbying for the subject.
Mm-hmm.
But it should definitely be, and it also says general about public health, about indoor environment.
Mm-hmm.
So it's there. But maybe the next one we should focus more on light and noise, because we cannot do about, and especially with the noise. If we don't do a good job on that side, you can see that in newspapers like, okay, let's not do the energy transition because it gives all kinds of noise issues. So we don't want that.
Right. Okay. Anyone? Oh.
Just to say that the definition is saying such as.
Yeah, but you know.
But that's true.
But you can overlook the such as. I'm not very quick.
I think air gets a lot of attention because it is easier to address. As a building services engineer, you can specify the right equipment to do that without potentially the architect getting involved. But from an acoustics and lighting point of view, sometimes it's in the viewer's hands.
I'm just asking because I was recently at a conference in Stockholm and I was sleeping in a windowless room. I specifically selected this one just to have an experience to how to sleep in a windowless room. I don't know. I mean, and then noise. Noise is a really issue related to the portable air cleaning solutions for the infection control. And here I would really like to think about what about the infection control? Because we were talking about, I mean, generally resilience of buildings. Resilience of buildings with respect to indoor environmental quality is a very broad spectrum. It is not only the overheating, it's not only the pollution from wildfires, but it's also to make the buildings resilient against the potential infection in the future. Any thoughts about that?
Just very shortly, I talked to a lot of people that think the next pandemic is 80 years from now, because the Spanish flu thing was like even 100 years ago. I've also talked to people who know the subject of specialized infectious disease. They say we had like near pandemics 3 or so the last 20 years. So it's quite likely that we'll have the next one in 20 years or so, not 80 years. But a lot of people that make decisions, they cross their fingers and they think, okay, COVID is gone. We don't have to think about this anymore. So yes, we will keep on defining ventilation requirements with just olfactory comfort, for example, which is naive. I think I know where you're getting it. So we should talk about this. We should.
So you think that one of the parameters that we could maybe propose should consider that aspect?
What I'm half involved in the EN 167981 group that looks at air quality and ventilation. I'm officially only involved in that. Some of us here are involved officially in the other one. What I would like to see is that there's some kind of an A+ category defined, maybe 50 liters per second per person, and then it has like a remark saying that, okay, you should have an option that you can increase ventilation in rooms with this setting, then the noise criteria maybe don't apply anymore. So if you do have like a period where a lot of people have influenza, you can go up to a higher level. But this, I know this discussion is going on within the group, with Jarek also involved. Maybe you can say a little more about it.
Right.
Yeah, in the revision, the objective is first to list what can be the objective of indoor air quality management system. And those objectives can be reached in everyday life or in case of disruptive events. And also what we will give here in the standards is the list of objectives that you can define for your ventilation system. And one of these can be, okay, you want your ventilation system to be resilient in case of pandemic, so that the building can be, you can continue to use the building just as it is when there is no pandemic.
Mm-hmm.
It will probably not be mandatory because you may have other strategies such as dividing by 2 the occupation of the building, but at least the standard should give the key on how to design in case you want this objective for your building. And that will not be mandatory because it's not the standard indeed includes this resilience aspect. And also another objective could be that you should be able to continue to live in the building when there is a wildfire outside. And in this case, you may want to design something that is still able to provide acceptable indoor air quality without using outdoor air. But that's, yeah, open things. And the standard, what is important is that the standard will list all elements and that we will be able to say all of them, but at least as much as possible objective you can have for indoor air quality management system.
And then Pierre and Tayo.
I touched upon this point a little bit in my
Yes.
remarks, but clearly during the COVID crisis in France, there was a really difficult situation in schools, basically, and there were some recommendations which were given by other scientists advising the government of what should be done. And clearly, there was a link which was made between confinement rooms and the spread of the virus. It was required that we should not go above a limit of 800 CO2 in those rooms, and then implement solutions which will allow to not go above this limit. So, I mean, then you have to think about which solutions allow you in such a situation to comply with such requirements.
I'll add quickly that I think part of the opportunity and challenge for this group is looking outside of the EU for other groups that are solving for these same problems.
Right.
And I know this one hits home for Pawel Wargocki, the American Society of Heating, Refrigerating, and Air Conditioning Engineers. 1 year ago, almost to today, released a new standard called ASHRAE 241 about infection risk management in buildings. And there's also a guideline that's being worked on for wildfire smoke control. So lots of great international collaboration opportunities here for reference standards for the work that's being done.
Right, so just to conclude and maybe allow the audience to ask the questions, and I know that we are running late. And then maybe one point that I'd really like to raise maybe and to have your opinion is that should we actually redevelop the wheel or start looking at the solutions that already are working when offering the input to the guidelines that Pawel and his group will be preparing? Because there are different guidelines and standards around Europe, some more and some less, working well. And then maybe we should look into this. For example, Finland has some solutions, maybe Sweden has some solutions, maybe France and Netherlands has some solutions that are actually very effective. And we can take from those successful stories and create a list of the parameters that we should follow. What do you think about that? Maybe this is a just rhetoric question.
One thing I noticed also within the standardization committee, if you put a lot of academics or like installation technology people in a room, they always come up with ideas how to improve it, make it more complex, to make it thicker, whatever you're writing. And then, of course, policymakers look at it and say, oh, it's all very complicated. Let's maybe not do it, or we allow them for another 4 years to talk with each other, and then they maybe come up with something useful, which is very short and simple. And I think what Pawel was saying is that it needs to be simple. I mean, it can be simple. You can have one A4 that's saying something about, okay, these are good numbers for daylight penetration. Right. These are maximum noise level inside. Yes, in those contexts, you want an operable window and an option in winter where you can adjust manually the temperature. They maybe should put people like us in a room for just 1 day and say nobody goes home. After you agree with the whole group on one page where you just write down these things, then it can maybe be done. But if you do it in a regular standardization context, it's always going to be more of this and more of that. We make it too complex maybe for decision makers. Now I'd like to hear somebody who disagrees with me.
No, completely confirms this, and I think the main challenge is probably the translation of this 300-page, very long text with many details, where it's kind of difficult to follow this discussion, and then for policymakers, make it a bit easier, and also for the public to understand what do you mean with those 300 pages. Because when they just read the PDF about IEQ, for example, then they're probably confused. But and this kind of summary would really be a benefit, and I think there's already so much expert knowledge in those documents that we don't have to start from scratch to come up with new research.
When we were developing the air-rated standard, rather than write everything from scratch, it heavily references other standards there globally around it, because it's much easier.
The other option is also to base it on some of the regulations that are already in place in different countries, so that they do not have to start from scratch. Is there any question from maybe the audience online? And if not, I will allow a couple of questions here. I will start with the lady.
Thank you. I'm Anna Bayomi. I'm an energy poverty policy officer at a social NGO. I focus on the unfit housing stock and how the green transition is impacting the most vulnerable groups. While doing my university studies in social policy, I visited many families in rural Hungary who are heating their homes with solid-fuel burners, and as later I learned by studying the Hungarian renovation plans, they are also occupying these performing building stocks, which are quite far from ready to accept modern technologies. And in fact, they are also not only poor in the context of Hungary, but
Hungary is also the third poorest country of Europe. And I'm really interested in indoor air quality because I feel always horrible after going home from these family visits to my apartment, which is a bit better than theirs. And and during this event, I was a bit disappointed that I couldn't hear about the most serious problems of all European households that are living in the unfit housing stock, maybe the poorest 10% of all Europeans, which is not only a problem in Central and Eastern Europe, also in France it's a big issue, but the French government is at least doing some efforts to target renovations in that segment, while in Central and Eastern Europe this is not happening. And I'm very happy that the industry is seeing a big business opportunity in the new legislation. So I would like to ask if the industry would be interested in developing some maybe corporate social responsibility action to, after installing maybe 100 new technologies in the wealthier households, then installing one in the 10% poorest households in Europe, making sure that those households that are heating with very polluting solid fuel burners and living in moldy and very humid apartments, hardly heatable, will also benefit and maybe save some months from their lives, which is probably around 10-15 years shorter than an average life expectancy of wealthy households.
Anyone?
I found it a challenge, knowing what I knew about air pollution exposure at home, preaching about air quality primarily in commercial offices, like the best buildings in the world, people who have the best air quality, meanwhile not addressing where people are exposed to the most pollution, which is typically in their homes, and it is a very important place. But a lot of it probably needs to come through education, certainly around the type of devices that people are using, what products they're using, and how they heat and ventilate their home. That can make a big difference. So I think that is the way to have the biggest impact is through education initially.
Anyone?
I think it's a very good question and remark, because I think that in the way that we will implement indoor air quality requirements, we shouldn't lose sight the bigger picture and of the energy picture, which is linked to buildings. And really, you point out to something which goes a little bit beyond technical solutions, which can be implemented for dealing with indoor air quality. But at the same time, there is one element which can bring its contribution towards the problem that you're raising, is the fact that when you address indoor air quality, you have to renew air. When you renew air, you incur thermal losses. And when you incur thermal losses, you incur energy consumption. And I think one aspect which is very important is that you find the right balance between addressing indoor air quality requirements and at the same time minimizing thermal losses with rise of addressing this. Here you have some industrial solutions which allow you to do that, and it's only part of the answer to what you were raising, but I think it's an important part.
All right, and two more quick questions, one here, and then we will close.
Thank you. It was actually a reflection based on what you said earlier, Adam, saying that all the parameters concerning indoor environmental quality are around the heads, the eyes, etc. And I thought maybe the next stage, what we could look at, is to see if we could not have a monitoring that is also happening at the body level, where we see more and more devices that exist. I mean, you can count your steps, you can count your calories, etc. And people are interested in that. So there's not necessarily a need to make them aware. So it's a useful awareness tool. And we could envisage that in the future, basically you would have a dialogue between the monitoring systems of the buildings, and they could give them in real time some advice to the person, some feedback to say, okay, here for that specific roof, we need to the ventilation system needs to adapt, or we need to open the window because that's the best situation. So I was just inviting everyone to, since we're discussing a human-centric approach, maybe we should also look at the technologies in there and how we can bridge between the human and the building side of the technology.
Great, thank you for the comment. Now I'll allow one last question with some of our panelists have information.
Thank you, Pawel. Just really a comment as we were discussing healthy buildings. There was a study published today that between 1980 and 2020, air pollution led to 135 million of of deaths. And the study got really, despite the EU elections, a lot of visibility from EPBD. So I really think that focusing on BOC levels, focusing on particles, on healthy buildings, is something that can bring back healthy buildings. Thank you.
Thanks, Christina. Thank you all for staying with us so long. And for other discussions, reflections, there will be opportunity after closing this session. First, we want to thank all the panelists for their comments and reflections. Okay, so first of all, I don't want to repeat what I said. We are actually adjourning that session, and then we will be going and this continued discussions over the drinks. Thanks a lot to our esteemed panel for the comments and the reflections. Thanks. Once again, thanks to the organizers, and thank you to you that you came here and you stayed with us so long. We are late as usual, maybe a minute. But still, the program will continue. Thanks also to all that are staying with us online. Well, this is Monday. I hate Mondays, apparently, and it's a very long Monday. So thanks a lot. And then you will hear from us more. Thanks a lot. And then the last one.
Also, a big thank you to you, Pawel, for smoothly guiding us through the second session. Also from my side, thank you very much. I prepared this slide specifically to say thank you in all the languages, official languages of the EU, because in a similar fashion, the 5 organizations that you see listed here, some of them are not that visible at the bottom. On that slide, you can see all of them precisely. So we went on this similar pathway, so we decided to go farther together as opposed to faster. So let's continue doing that. We still have a networking side of things for today, but let's continue going farther together as opposed to fast alone, because this is needed. And all the exchanges we have had here shows that we have the expertise. We are able to work together. Although we represent maybe different interests, there are some of us that have a really horizontal nature, and we see indoor environmental quality in a holistic manner. So I think the technical things are there, policy is coming along, financing, I think we will find solutions, but we need to have coherence. So I think this is where we need now to work really on, to ensure coherence at all levels, global, European, national. So thank you very much from my side. We can discuss after.
The slides are available.
Yes. So all the slides